My name is Kenna Kettrick. I'm a program manager with the OCI go-to-market team. And today I'm joined by Somnath Lahiri, a principal product manager here at OCI, who'll be taking you through this presentation on event-driven architecture. Before I hand things over, I do want to run one quick poll. If you've been with us before, then you will recognize this. We design these events, these weekly deep dives and our other series with you, our users, in mind. So I always like to hear what kind of topics you're interested in so that I can tailor what's coming up to that interest. Speaking of which, we do have an event next week on Thursday, September 9th. We're hosting Saurabh Shah for a deep dive on automated software developments using the OCI DevOps service. I'll drop a link to that registration page in the chat right now. So if you're interested, I hope you can join us for that. It's going to be super fun. And I'm also going to drop a link to a survey that we're running with our OCI customers. As mentioned, we love hearing your feedback. We love to hear your thoughts. So if you can take 1 or 2 minutes at some point today and give us that feedback, we're happy to receive it. And then our usual reminders, please feel free throughout the session today to drop those questions in the Q&A box at the bottom of the screen there. We'll be answering them throughout and also have some time at the end for some dedicated question and answer time. And we are recording, of course, so there will be replays up available afterward. If you have friends or colleagues you think might be interested in this that couldn't make it, we will have replays available for them as well. All right, I think that is enough from me. Go ahead and take it away, Somnath.
Thank you, Kenna. I'm going to share my video so it doesn't seem like I'm playing something from the background. Hey, folks, thanks for joining. I'm really excited to talk about this topic. This is near and dear to my heart. We do it on a regular basis. So without further ado, let's get started. So we are going to talk about event-driven application development using Oracle Streaming. Obviously, there are many other choices, but we are going to focus on what our customers are doing, both enterprise as well as modern cloud-native startup companies. So let's go ahead and talk about our agenda today, what we are going to do for next 35 to 40 minutes. So we'll establish what is an event-driven architecture, give an example, and then go into what are the OCI offerings or Oracle Cloud's offerings to help you build event-driven architecture. And then we'll go on and take you through some use cases. First, we'll talk about an enterprise application, one of the insurance company that is using streaming, how they evolved into an event-driven architecture. Then we'll talk about an e-commerce app, order pricing app, and show a demo around it. So you get the understanding, not just the theoretical part, but how it actually works. And then finally, we'll talk through some event-driven design principles. As a developer, what are the things you need to keep in mind when you are designing this event-driven application? And for the rest 10 minutes, we'll do some Q&A. So feel free to put your questions in the chat. Manish is joined by me here. So both of us will try to answer as many of your questions as possible. So with that, let's get started. This is the standard safe harbor statement. We are going to talk about some stuff which is now roadmap. So yeah, you know what it means. So event-driven architecture. For this, I'd be interested how many of you have used event-driven architecture. Kenna, if it is possible, if you can bring up the poll about event-driven architecture, I'd be interested to understand, are you using it? You're not using it, considering it? I don't know what it means. All answers are great. Okay, cool. Yeah, I think, this is a great split. There are people who are actively using it. There are people who are considering it, and then obviously there are a few people who are not using it. So I think this is we have content catered to all this audience who are using it, who are considering it and how to do it, what are the best practices, as well as giving the fundamentals to folks who are not using it yet. So what is event-driven architecture? I'm not going to explain what it means. I'm not going to establish in a canonical form, say this is what is event-driven architecture. Instead of that, what I'm going to do is I'm going to give you an example. An example of an application we all know about, e-commerce order pricing app. Hey, this is nothing new. We all use it. We know how it works. So we have the mobile app where we place the order. As soon as we place the order, it goes through the payment processing. If everything is good, the order finally goes through the warehouse, where the warehouse system pulls the order, and something happens in the physical world, that they have a bunch of processes. They fetch the order, and after a few minutes or within an hour, a day, or after a few days, the order arrives at our doorsteps. So this is a typical example of an event-driven architecture. Now, if we think about the communication between the order processing app and the warehouse, what happens is that, in cases, there are thousands and millions of orders that customer place in a particular day or a particular span of hour. So the communication between the order pricing and the warehouse fulfillment system has to be able to ingest those large amount of events, large amount of data that is placed by the customer. Also, if you think about it, on a typical day, on certain occasions, during the certain period of the year, there are many orders. Customers are placing, thousands of orders, but we don't want to push all the orders to the backend warehouse fulfillment system at the same time, because warehouse system can't process the order at the same time, right? It takes time in order to process it. And in addition to that, if you think about a e-commerce application, it's not the warehouse system which needs this data. In typical earlier world, it was just the one system tightly integrated, which is calling the API, placing the order to the next system, but this doesn't happen anymore. In addition to the warehouse system, I need to send the invoice to the customer as soon as they place the order. As well as there are many other companies, many other departments within the organization that need access to this data. For example, I need it for the reporting purpose. I need it for the compliance purpose. My digital marketing team needs access to this data so they can show the corresponding advertisements or what else to buy with the item the customer just bought in addition to it. So it's not just the warehouse system which is accessing the data. We need to have an application of need of a fan out when this data is being generated. So what I'm trying to say here is the world has evolved to a place where the order processing system could just say, I don't know what other downstream system it's going to use my data. I need to persist the data somewhere. I need to put it into a messaging system where it can scale infinitely. And from there, they can fan out that data to the corresponding downstream system. So warehouse system can take it. Compliance system can take it. Digital marketing and all other systems can access this data at their own pace. So if we think about the requirements here, just going to minimize the screen. If you're just going to think about the requirements, it's about the scalable ingestion. So whenever the orders are coming, some system needs to be there which is able to ingest those millions of orders that is coming out. The system should be able to fan out the data, so not only warehouse system, but other departments and system can access this data and do their specific job. I need to have a durable storage that I can't lose customer order. Whenever they place the order in my e-commerce website, I'm showing them, you place the order, you can expect the order within next 2 days. I can't just lose the data at any point. And as I mentioned earlier, the system should be scalable enough to handle the load swing. So, during certain time of the day, during certain time of the year, or whenever there are promotions going on, There are millions of orders which should be backed up. The warehouse won't be able to fulfill the orders at the same time. So the system should be able to handle the load swing. And what are not the requirements here? We don't need the exactly one semantics. My backend system is robust enough to handle it. We don't really need strict ordering. If I place the order, Kena place the order, or Manish place the order, I won't mind if they are I place the order 2 minutes before they get the order first, right? It's not a deal breaker. And I don't want the system, my messaging system, to push the order to the downstream system, because as I say, downstream system works in a different way. It has complex processing logic. It takes time to process my orders. So I'd rather want the warehouse system to pull these orders from the messaging system rather than getting pushed to it. So as you can see here, what we have transcended to a world where everything is driven by this order process, or this messaging system, or the eventing system, which is help build this internet scalable applications. Instead of having this tight coupling, I am having the loose coupling. The order processing system says, instead of integrating deeply with this warehouse API or other APIs, it says, I don't need to deeply integrate with anything. I just need it to send somewhere, which will give me the acknowledgement back that I have purchased the order, and I can move on from that point. So instead of tight architecture, I'm moving to a loose architecture. I'm event messaging here. I'm just pushing the event, and event is the self-contained transactions, which has all the details the downstream process need, and I'm done with my job at that point. You need to scale the application. You need to have multiple fan outs. You need to have other departments which wants to access the data. Not a problem at all. It can just access the data from the message queue. So is all the requirements always the same for a event-driven architecture? It's not, right? It depends on what you need from that. So I hope this gives you an example of an event-driven architecture and why it makes sense. Why instead of this tight coupling, we're thinking about event messaging system. Now let's try and give you an example of what does an event mean. I mentioned during event-driven architecture, I'm not going to give you an example or definition what an event-driven architecture means, but I'm taking a different position here. So I'm trying to define what an event is. So event could be in action, that someone placed the order in an e-commerce website. It could be a state change. For example, in our OCI, we have a product called OCI Event Service, Cloud Events, which emit events whenever a state or a service changes state. For example, compute changes state from provisioning to active. So this is just an example of an event. It's self-contained transaction. This is complied by the cloud events, CNCF committees and foundation. But the whole point is that you can create your event, which is self-contained transactions. So whenever in the previous example you mentioned, the order processing system is pushing the order, pushing the event, it should be self-contained. That warehouse system doesn't need to go back to the data source and directly interact with order processing system and ask for more information. It should have all the information that all the downstream system needs. So, so far we established what an event-driven architecture means, what is an event, what is an example. Now let's look at how OCI can help you build an event-driven architecture. What are the offerings we have? So we have, 3 specific offerings in this case: streaming, queue, as well as PubSub or notification service. So let me just give you a small primer on each of these service, then we'll go deeper into the streaming service. So streaming is a eventing log. It's an append-only log, which helps you build internet scalable real-time application. It provides you additional guarantees such as you need ordering guarantee, you need message replayability. that you can get from streaming. I was talking about the fan out. This is one of the key pillars of an event-driven architecture. Streaming provides you that. On the other hand, queue provides you this durable message buffer. It doesn't provide you strict ordering guarantee. It gives you the best effort ordering. But in cases you need queue where you have to have the concurrency, like concurrent consuming pattern. There are multiple consumers who want to access the data from the queue. And PubSub, or the OCI notifications product. So for streaming and queue, in order when the consumers need to access the data, it needs to pull the data. Whereas for PubSub, it just broadcasts information. So whenever something appears in a topic, it broadcasts to thousands of subscribers, which is subscribing to that information. And some of the use cases are, you want to have the app integration, you need to fan out to a large number of subscribers. That's where you use the OCI notification service. So out of this, streaming and notification, these are already in GA for some time. Queue, that's the new product we are launching. It's currently in internal limited availability. We are accepting registrations from external customers to try it out, give us feedback about the service. So feel free to put it in the chat or in the Q&A section. If you want to have access to the queue limited availability, I'll be happy to set you up with that. So with this, in this today's session, we'll talk specifically about streaming service. We'll come back and do sessions on queue and PubSub in the future, but let's talk about the streaming service. There are other products in the market. Yeah, so I think in this point, let's hold on. Yeah, let's do this. For streaming, we are Apache Kafka compatible. Instead of hosting your own Kafka, we know it's a pain in the back. We are providing a managed serverless Kafka. In addition to that, we have many of the other enterprise specific features, security features, which is not there in Kafka. So think about of this solution as a managed Kafka, but it offers you more. Right, cool. I think a lot of people use Kafka here. That's great. We'll spend a lot of time talking about this specific service. So, why you should use streaming, right? What does it provide? As I said, it's a managed Kafka offering. You don't have to host Kafka. You don't have to deal with Zookeeper and everything. Instead of that, it's a serverless offering that gives you all the functionalities. It's deeply integrated with monitoring. So instead of having your own Grafana and everything, you get all this functionality out of the box. It's fully secure. We encrypt all your data at rest and in motion. In addition to that, it supports private endpoint, right? In many of the enterprises, that strict requirement is that I'm not poking any hole in my VCN. I need to have the service endpoint accessed from my VCN. So that is what it provides through the private endpoint integration. And it's a scalable service, right? It scales up and out as needed. As you know, there is the concept of partition in a stream. So if you need more throughput, you can add more partition to the stream and it can scale up. And obviously, for any enterprise system, you need the fault tolerance. It replicates the data across multiple availability domains, which are in distinct locations. And it provides you the high availability as well. Even if one of the ADs goes down, the service is still up. And it provides you an enterprise grade SLA. So obviously, at this point, you might be thinking, okay, other cloud providers are also providing me the same thing. So what is the difference? Like, why would I use streaming? The reason you use streaming is because of this. We are the only provider in the market which provides pay-as-you-use. You go to other cloud providers, they charge you as soon as you create the resource. As soon as you create the stream or topic, they keep charging you for it. But in OCI, we have this notion of pay-as-you-use, doing right for the customers. So you pay only when you push data, get data from streaming, and you store data in streaming. You have zero lock-in as well. We have Kafka compatible. We are going on a roadmap to be fully compatible with most of the rich Kafka specific features. Right now, we kind of offer around 70% of Kafka compatibility, which is good enough for most of the enterprise use cases at this point. In addition to that, we have rich integration with Oracle first party as well as other third-party software providers. And you move data out of streaming for free. For example, you want to do serverless processing using streaming and our functions, you can do it. And there is no cost of transporting data from streaming to functions or streaming to any downstream Oracle application. You want to move the data for object storage for batch processing or just storing the data for longer period of time, you could do that as well. So these are the reasons you should actively consider building on Oracle streaming. All right. Obviously, as I said, it's fully open source compatible. So you are getting all the benefits of Kafka without having to host it. You are getting the access to the open source ecosystem as well. We support Kafka Connect. I'll show you an example. It's just coming up. How we can build application using Kafka Connect, event-driven application using Kafka Connect. And it has the full Kafka compatibility. As I said, we have the streaming API as well. So, if you want to interact with the service with our API, with our SDK, you could do it, or you could use the open source streaming API. This is just confirming the same point that I mentioned earlier. You could use Kafka connector to connect with third-party systems, flow data out of streaming as well as move data inside streaming. And we also have our serverless connector for inside Oracle like services like object storage. You could use service connector to move data out of streaming. So it provides all the benefits of Kafka ecosystem. You could use the Kafka mirror maker as well. One of the most popular use case of this is I want to replicate my data in separate regions just to be DR proof, disaster recovery proof. This is one of the requirements for enterprises. So we have built-in support for Kafka mirror maker. And finally, I'll show you in my demo, in my code, that how easy it is to migrate from your on-prem Kafka to OCI. It's just about changing the endpoint and restarting your application. So you, instead of pointing to your local Kafka endpoint, you just build the connection string and point to our endpoint. So it's as simple as that. And finally, with that, I hope you got a decent understanding of this, what OCI streaming provides, what are the advantages of it. Now let's shift gears and focus on an enterprise app, how you can make an existing enterprise app event-driven. So this is one of the customers who use OCI streaming. So they are a big insurance company out of like Europe. Excuse me. So what their ecosystem was, or their system was, if all of their system was on-prem, their customer management system, their policy servicing, their claim processing, insurance quoting, all the system were on-prem. And obviously they were trying to modernize their applications. They had requirement of, there are many other departments which need access to this insurance data. And they want to be event-driven as well. For example, if something changed, they want to respond to that customer query at that point, instantaneously. So, the specific use case that we are talking about here is, it's a travel insurance company. They provide travel insurance as well, car insurance as well, travel and car insurance. So what happens is that, or the requirement is that, whenever customer changes his or her address, automatically the insurance quoting system should fire up and it would generate a new quote for the customer. As we know, it depends on which zip code we are in, and there are various other factors. which impact the insurance, how much premium we are going to pay. And they had scaling challenges. But they didn't want to move all their on-prem system to the cloud. So what they did is this new kind of applications they wanted to build, such as whenever something happens, for example, the customer changes the address, the customer should be able to get a new insurance quote instantaneously, and there will be a new ID document, new policy document, which should be emailed to the customer, or they should be able to access those documents through the app instantaneously. In addition to that, we needed the data for digital marketing purpose. We want to show new offers, new things for the customers, so they can build on this. What we did for this customer is they use streaming for replicating all this order and customer data in cloud. So we use the Kafka connector. We use the Debezium Kafka Connect in this case. So what it did is that they used Oracle database on-prem. So whenever something happens, all this change data we are capturing through the Kafka Connect. As I said, you don't have to build anything for this. Kafka Connect is readily available in the marketplace. You could use it. And they're using this Kafka Connect to push all this change data capture, change data log to OCI Streaming. And all the downstream system then can use that data. The insurance quoting system is getting the data from the streaming, and as soon as it could fire a process and get a new quote and send an email to the customer. Hey, we have seen you have changed your address. Now this is your new insurance quote. Similarly, insurance doc service and others system could issue these new docs, new policy documents, new ID documents, and they could send that information to the customer. They could access that information via the app. So as you can see, how an enterprise could also, transcend on this journey of being event-driven with this application, right? They could use streaming, they could use the Kafka compatibility features to move to an event-driven architecture. Now we'll look into a demo of an order processing system. This is another customer. This is an e-commerce customer who is using streaming, but they are more of digital native in this case. So what they are doing is that they are taking all these orders. The requirement is that as soon as an order goes from customer places the order to the warehouse to the supply chain system, and finally the delivery company fulfills the order, it goes through multiple processes. And as it goes through multiple processes, each system emit an event to the streaming system. Hey, here is an event of what this particular order went through. This is the metadata of the event. Now, the requirement is that we were going to build a tracking service out of it, that customers should be able to see in the mobile app what is the exact status of this order, and the requirement is that there should be a strong sequencing guarantee of it, that we should be able to see exactly what is the latest status of an order, and it should be in sequence, right? It should be at first customer placed the order, warehouse is working on that order, the delivery partner is fetching the order, and finally it got delivered to the customer. However, in addition to that, as I mentioned, the PubSub is another use case for it, that there are other systems which should be able to access the order, and store it somewhere else. So, and there are other things like, we need to store the order for a long time, and there should be multiple reads out of the streaming system. Each system should be able to read the data at its own pace. So with that, let's see a demo of how this might actually work in real world. All right, so in this case, I hope you are able to see my screen here. Just give you a small background of what we are doing here. There are a few things, we are interacting with streaming via Kafka admin APIs, as well as Kafka produce and consume API. As you can see, what we are doing here, we are building the connection string, and then we are creating the topic or the the streams here. We are passing how many partition do you need. So partition is the single atomic unit of a stream, where accepts the data based on my ingestion volume. I can increase or decrease the number of partition. So there are other sides. On the one side, there is the producer, which is producing these events to this Kafka topic. And there are consumers, the tracking application, for example, which is taking the orders out of the streaming topic. So as you can see, we are always using the Kafka API to interact with it. So it's a managed Kafka, as I said earlier. So without further ado, what we'll do, we'll create a topic, say e-commerce orders. Let's create the topic with 3 partitions. So we are creating this topic at this point. So as you can see, it has successfully created the topic, e-com orders. And we can go into our OCI console, you can see that the topic being created. Now what we'll do is that as the order moves through multiple stages, the order processing service, say, we want to go to order processing service, and we want to produce data, right? As soon as customer places the order, it captures that particular event and emits an event to streaming. So here what we are doing is that we are sending data to the producer instead of programmatically doing it. I'm showing it manually. I didn't want to build the end-to-end use case over here. So what you can do is we can produce some events to this. So it's more like customer placed the order. Then we can have similarly other events as well. That once these are the specific order ID keys. So as you know, the streaming has the concept of partitioning key. So based on the order ID, it's make sure that all the events that is produced in the streaming is in order. So similarly, if there is another order which comes up here, we can also emit the same event, that customer placed the order. We're just going to copy this thing and create few more orders here. 103, customer placed the order. 104. As the new orders are coming up, we can create more events. Similarly, what we could do here is, as the order moves through the further downstream, it goes to the warehouse service and everything. So similarly, we could go through that process as well. So what we can do is that similarly we could place the orders. So for the same partition, same order ID, we could say that, say 101 or 102, that warehouse is working on that order. So as you can see, as the order goes through multiple steps, it's like the multiple producers are emitting those events to the stream. Warehouse is working on the order. So let's just start this producer application. So we can produce this thing that warehouse is working on the order. So what I'm trying to show here is that you can have multiple producers, and then you can create the consumers as well. So these producers are producing the order, and similarly on the downstream consumption side, we can have this consumer which is consuming the order from this, or consuming this event from the stream. So as you can see, we have started the consumer here. It will start pulling the orders that we have produced to the stream, right? So similarly, we can have as many consumers we can have. That the fan out guarantees that we are talking about, it can have as many consumers. The size of old record is 4. So it started pulling the orders that was already there. That is getting to the stream. So I'll update this thing. As you can see, it is consuming these orders from the stream, and I can have as many consumers as possible. And each of these consumer groups are distinct from each other. and they can get the orders at their own pace. So I hope it gave you an idea about how you can build this event-driven architecture where the multiple producers are producing events on the downstream side. The consumers don't know about these producers and they can consume the data at their own pace. So let's switch gears for the interest of time. So hope we are able to understand what are the aspects we need to think about. Now, lastly, I want to give you an understanding about what are the characteristics you need to think about when you are building an event-driven architecture. For some application, you need strict ordering. For example, this tracking application, you need strict ordering. All the events should be in sequence. However, in many cases, you don't really need ordering. For example, the order processing application in an e-commerce site, or the customer changing their address and some process being fired. Those events are independent from each other. So you don't need to maintain this ordering guarantee. And your choice of application would be based on that. For example, streaming offers strict ordering guarantee, whereas Q or ONS or POPs-up does not do that. So you could use your application based on that. So next is the delivery guarantee of at least one versus exactly once. Obviously, my recommendation in most cases, it's the cloud messaging system provides at least one guarantees that whenever a message comes, it would be delivered to the downstream system. In many cases, you may need exactly one semantics, but my recommendation would be to handle in the consuming side. So maintain kind of a key value pair, and you drop the message. If you see, you have seen the message before. I know Kafka provides the exactly once guarantee, but there is a cost of it, right? There's increased latency and everything which comes with it. Then again, point-to-point versus publish subscribe. There are different messaging patterns. The event-driven architecture is a classic example of publish subscribe. You push the events, and there are multiple downstream systems which needs to subscribe or get access to the same data. That's how you make sure you can scale your application. Pull versus push. Personally, I prefer pull. The reason being, and I recommend using that. The reason being, in many of your downstream application, it may not be able to process fast. And whenever you are agreeing that push message to me, you are basically committing that, whatever the rate is, I'm going to process the message as soon as I get those message. But all the applications doesn't scale at the same level, at the same rate. So that's why, it's better to pull the messages. Whenever the downstream application is ready, they can consume the message at their own pace. Then the choice becomes about managed service versus self-managed broker. As you said, many of you are acquainted with Kafka, RabbitMQ, ActiveMQ. And there are managed services like OCI services. However, what we are doing in streaming, we are combining all the greatness of these open source services with the manageability part. So our recommendation would be use the managed services, but use the open standards, open source API. So you're not locked into a specific vendor. There are also the concept of the homogeneous events versus heterogeneous events. For example, in the order processing system, we could inject multiple other events types to this particular stream. However, dealing with heterogeneous events is complex. So my recommendation would be to use homogeneous events in your topic or in your messaging system. Latency profile, that's another aspect which comes up very, very often. Obviously, you should look at latency. I hear customers saying, okay, I need a latency less than 5 milliseconds. But if you think about it, it doesn't mean anything. In cloud parlance, it's all about what is the P90, what is the P99. So I'd rather encourage you to run your own latency profiles with the applications that you want to run and see what is the P99 or P95 that you are getting out of it. That 99% of the time, you want to have your latency less than, say, 50 millisecond or 100 millisecond, depending on your application. And finally, in Kafka world, people use the data blobs, Avro, Parquet, Protbuff, and all this, way of putting your data versus JSON. Well, people think that, if you're putting data in the where, it's generally faster because, it's already in data blobs. But I haven't found any canonical example or results which shows that, hey, Avro or Parquet is significantly faster than JSON. So it depends on your organizations, what your developers are acquainted or familiar with. So overall, I hope it gave you some of the thought points or some of the pointers to think about when you are building your event-driven architecture. Like, what are the things you should keep in mind? Finally, let's go into the Q&A part. I'll try to take few of the questions.
Sure. Thanks, Somnath. So
sure.
That was a great session. There were lots and lots of questions. I have left some open for you, so I'll go through them in the list so you don't have to read through them.
Okay.
But every time we do this session, I learn, talk about the services. I learn something new from you. So awesome. So I think one of the questions is, does OCI Streaming compete with Confluent Cloud?
Yeah, so Confluent Cloud also provides Kafka. They provide some other features in addition to Kafka as well, for example, schema registry and stuff. Obviously, in that sense, we could think about it's a competitor to Confluent Cloud. But if you think about it, we don't deal with the notion of brokers and stuff, right? It's fully managed as well as serverless. Customer just interact with a stream versus they have to deal with brokers and everything else. In addition to that, we have all these first-party connectors, managed connectors, versus you have to host your own connector, right, in Kafka Connect. So you can take data and move data to object storage. You can do the stream processing using functions and various use cases you could do. Obviously, there are like Confluent is being there for some time. They have some features that is not there in OCI Streaming yet, but we are aggressively working on these features like Kafka streams, idempotent producers, support for transactions. So we will be fully Kafka compatible in a few months from now. And in addition to that, we have many of these features, many of the enterprise grade features that Confluent does not have. So it depends on what you want at this point. We have some comparative material around how do we compare with Confluent. I'll make sure I publish that material with this particular presentation.
Okay, thank you. So the next question is, what kind of message delivery guarantees it provides? I think you answered this as part of the session, but do you want to quickly recap what you said?
Yeah, so we do at least once guarantees, and our recommendation is to handle with any deduplication on your consuming side, that you have transactions and dedupe the messages over there versus building it on top of streaming.
Yeah, you also covered this question, is underlying implementation for OCI Streaming actually Kafka?
Well, it doesn't matter for a customer what the underlying implementation is. What we are guaranteeing is that we are guaranteeing compatibility with Kafka. Correct. Right? You interact with Kafka API, so you don't have to change anything in your application.
And is it possible to integrate Kafka with Golden Gate and Oracle Cloud Integration Cloud?
Yeah, it is possible to do with Golden Gate and Oracle OIC, Oracle Integration Cloud. I'll publish this thing has some useful links on how to do it, how to do the integration with autonomous database, ATP, ADW, as well as on the producing side, how do you capture this change data capture from Golden Gate and push into streaming. And with the OIC has a streaming specific adapter that you can use.
Okay. Does it support KSQL?
It does not support KSQL. The reason being KSQL is proprietary to Confluent and it's under Confluent license. so we can't really support KSQL.
Thanks. The examples that you covered in your demo, are those available on GitHub, or do we plan to share them on GitHub eventually?
Yeah, both the examples are available in GitHub. So previous to that, I showed an example of an insurance company that we are working with, how to set up the Kafka Connect, how they are doing it. So I'll publish both the GitHub links. The other demo I didn't have time to show it, but I'll make sure I publish the GitHub link.
Okay. Couple of more questions left. In
Sure.
what scenario would you use OCI streaming versus Oracle ATP AQ streaming, transaction event queues?
Well, the streaming is used for large amount of data processing, and it provides you certain guarantees like ordering guarantee, where you have you want to ingest huge amount of data within a short span of time. That's where you use Oracle streaming. Obviously, Oracle AQ is more in the context of Oracle database. Q has other use cases. For example, it doesn't allow multiple reads. Once you read the data from the queue and the consumer acknowledges it, the data is gone. So for the event-driven architecture scenario, I'd encourage to use streaming because it allows the pub/sub capability, so multiple system can read the data at their own pace. And that's one of the essence of event-driven architecture as I think of it.
Okay, what kind of message delivery guarantee does it provide? I think you talked about this.
Yeah, I already talked about it. Sure.
Yeah. What is the maximum retention of messages before they're consumed?
Yeah, currently we provide 14 days of retention before those are consumed. And for enterprises, we are building another feature within streaming, which will provide 90 days of retention and different retention tiers as well. So that feature we are actively working on. Hopefully by sometime next year, that feature will come up. Yep.
Okay, I think there's one question which I should ask and then stop here. How do we manage the time factor with downstream process? Example, the order placed, event starts to shipping service, sent to shipping service and waiting for acknowledgement. Order placed, shipping confirmation. I think it's better for you to read it. It's too long.
How do you manage the time factor with downstream process? Example, order placed, events sent to shipping service, waiting for acknowledgement, order placed, ship confirmation. Invoice, what is the minimum time consumption between the two services I have to consider for my design? I'm not sure exactly what it means. We don't have much time. I'll make sure I'll copy this question and I answer it somewhere. If Senthil Raj, if you don't mind putting your email address, I'll make sure I'll follow up with you on this particular aspect, how to design, how to think of the time factor. I'm not exactly sure what is meant by this.
All right. Thanks, Somnath. Thanks so much for the session today. It was really useful, I think. I hope the participants enjoyed it as well.
All right. Thank you, Manish. Thank you, Kenna. And thank you, folks, for joining. I hope it was insightful. You got an understanding what is how to design an event-driven application. What are the different factors you need to consider for it? Thank you again.
Yeah, thank you so much, everybody. There is a link in the chat for where the replay and slides are going to be posted. And I will post extra links there for like GitHub resources and things like that. So if you want to share those links with me, Somnath, we can add those to the forum.
Yeah, I'll make sure the GitHub repos and all the links are posted. And there are a bunch of other useful links. There are a bunch of other hands-on labs, how to process IoT data, how to do large-scale stream processing with Kafka compatible streaming. I'd highly encourage you to go and try those out.
Awesome. Excellent. Thank you so much, Somnath, for this presentation. Thank you, Manish, for jumping in and helping out with the Q&A. We had lots of interest, lots of questions. Thank you, everyone, for joining us today. If you haven't and you want to drop your thoughts in that final poll that I popped up, always appreciate hearing some feedback on that. But otherwise, please join us for more sessions in the future. Join us on the forum to ask more questions and have more discussions. And Somnath, maybe we'll have you back sometime soon to follow up on this really interesting topic.
Sounds good. Thank you, Kenna. Thank you,
Thanks,
everyone.
everybody.
Thanks for joining.